line and the reference surface. For field work, we say we use gravity line as the reference line and use geoid as the reference surface. But for computer, in homework, we use spheroid surface as the reference surface and use a line perpendicular to this surface as the reference line to compute. And then we talk about meridian and parallel. That means we can use longitude and latitude to locate the point of the surface of Earth. And another important point is rectangular coordinate system. We also can call it as grid reference. And compare with mathematical rectangular coordinate system, we have two different points and have one same point. And here, the axes are interchanged and the quadrant order is inverse. Okay? In some way, in this rectangular coordinate, we say the north is x axis and the east is y axis. But in mathematics, this is interchange. And the quadrant order is inverse. But just because these two different points, so we say the same use of plane geometry and trigonometry. The use is the same. Okay. For all for global, in this situation, we divide the surface of Earth into many sections. If divided by 6 degrees or by 3 degrees, we can divide the surface of Earth into 120 or here is 60 or 120 sections. For each section, we can establish a rectangular coordinate system. Yeah, we call it Gauss rectangular coordinate system. In this system, for each section, we use central medulla as the x-axis and use the equator as y-axis. Okay. Here is the third dimension. We say in real world it's 3 dimension. So if we will use longitude, latitude, or use x or y, just can locate the point in 2 dimensions. So we need the third dimension. Yeah, the third dimension, that means we need to describe the distance, the point higher or lower the standard surface. This standard surface, we usually use the geoid, that means the mean sea level at the standard surface. We say in this on this surface, we just say the elevation of points. The elevation is equal 0. So for a mountain, for the top of mountain or some points on the surface on ground, we say its elevation. Just means the distance along gravity line to the standard surface. If the standard surface we use the geoid, that means this distance is the absolute absolute elevation. But if the standing surface is just a surface you choose yourself for some certain purpose, some engineering purpose, it's just an assumed level surface. That means this distance we just say is called relative elevation. I think this conception is easy, yeah? But for absolute or relative elevation, something is not changed. That means the elevation difference is not changed. The elevation difference between points, for example, point A and point B, the elevation difference between these 2 points, you can use absolute elevation calculate. Also can use relative elevation to calculate it. It's equal H equal HA minus HB. Also equal here minus here, yeah? It's equal. So in some certain engineering project, the elevation system, if you define, you can use absolute elevation to accomplish the elevation control. Also, you can use relative elevation to finish that. But in one project, you can just use only one system. Yeah? You cannot use absolute elevation and relative elevation at the same time together. Yeah? You can just use only one system to locate the elevation of points. Okay, for a country, for example, in China, for whole country, we want to establish the elevation control for this country, so we must have one original elevation point. This point that means to locate the mean sea level position. The method is just, we use many years of observation to the location or position of the sea level. Or you just say the sea surface to observe is higher or lower, and many years and get a mean position. And this position we say is the geoid. It's the geoid. And then from the geoid we say here the elevation of point is equal 0. Yeah, is 0. So the seashore we just use a mark, or here use a mark. We say this is original elevation points. Use some instrument to survey the elevation of this point. Just means get the absolute elevation. And then use this point as the original elevation point of the whole country. And each control point's elevation in this country will survey from this point. From this point. Yeah? Step by step. Okay. Okay, so we have know how to establish the references system for 3 dimensions. So next, the methods used in point locations. Generally, we use this method to locate the point's location. Okay, here you can use this method to locate the point locations. Also can use this method to get the coordinates of the points. First is 2 distance. That means if point A and point B is given, that means we have known the coordinates of point A and point B. A and B, the coordinates we have known. So if we use instrument to survey what? Survey point C, and we want to locate point C position, or we want to get the coordinate of point C. So we can use instrument to survey. Survey what? Survey distance between AC and distance between BC. So we can use the triangle to calculate the coordinate of point C. I think this can be understand easily. Yeah. Okay. In survey, we say that we have two tasks in survey and mapping. That means first is survey and mapping. Another is survey and lofting. Yeah. Or layout. So we say the method also can used in locate point position in layout. Also can use the getting coordinate in survey and mapping. Just by the same method. Okay? This is use distance. And the second, we can use two distance and a right angle. Right angle. The third is one distance and one angle. And the fourth is two angles. Two angles. For example, two angles here is also a B. These 2 points is given. So if we survey here alpha 1, alpha 2, so the point C, we can locate it. We can locate it. Of course, the second and the third method here, this is one angle and one distance. Here, one angle and one distance, we can calculate the coordinate of point C. And also we can use it here, two distance and one angle. But this angle is special, it's just a rectangle, perpendicular. Yeah. So this, of course, we have other methods to locate points, but this is most popular, and especially the most important method among this here. This can use one angle and one distance. This is the most important method in locate the point location. Okay, and in the following chapters, we mostly use this method. And most of instrument is also used this method to survey the coordinate of a point. Okay, this is the method used in point location. If you don't understand how to calculate the coordinate of a point, and we will talk later. And to locate the position of points or relative position of points, some elements should be measured. That means these three elements is the most important things we survey in this subject, in survey and mapping or laying out. All activity of survey and mapping is about these three elements. We say, not the class, we say, if we want to get a bachelor degree or master degree or PhD, doctor degree in survey and mapping in China, all these 10 years, more than 10 years, we just research these three elements, okay, or X, Y, Z. Say, these three elements, one is distance, second is angle, and the third is elevation difference. So, for example, we will do 8 times experiments. This 8 experiments is just about these three elements, survey these three elements, and then use these three elements together to locate the points, locate the coordinates, locate the elevation, and use these elements, locate the coordinates, and then draw it on map, in map. Okay? These three elements you must remember: distance, angle, and elevation difference. We use d, beta, h to express the data. Okay? Okay. And you cannot change. You cannot change in the subject. Okay? Of course, maybe in your country and in other situation you can change, but here you cannot change that. Okay. For example, in this picture, we say why we say these three elements must be measured. For example, here is point A, if point A is given, we know